Okay, so last time we were doing 2019 statistics question, and from this paper we were solving subject probability and statistics. So paper is 2009 and year is 2009 and paper is statistics. And so far we solved few questions, right? Let's solve few more questions, and that we will be solving only those questions that will in line with the syllabus of data science and artificial intelligence. Similar thing I have done for the linear algebra, where I have solved last 5 year papers from EC, ST, and MA paper that you can refer. You will find that separate playlist for that. And also for this series, for the probability PYQ, you will find the separate playlist for that you can find in the maybe description. Okay, let's do few more questions from this paper. So let's pick this question number 27. Okay, so what we have given is the sequence of independent and identically distributed Bernoulli random variables, right? So Bernoulli random variable, what does it take? It can take either 0 or 1, right? With the success probability where we have given that p belongs to 0 or 1, right? Then as and tends to infinity, then this expression converges almost surely to, right? And we have given this sequence of independent, and so these are the independent. And so let me first of all so we have given this, right? Xk, and all these are the random variables and Bernoulli random variables, right? So we can have x1, x2, x3, dot dot dot, right? So all these are distributed Bernoulli. They can take either 0 or 1, right? Now we have this expression given that 1 by n summation k is equals to 1 and xk to the power k, right? And we have to find that if n goes to infinity, then where it will be converging, right? So if we open up this summation, then this will be x1 1 plus x2 square plus x3 cube dot dot dot, right, till x n to the power n, right? So all these are all these x's are these are all random variable, and it can take either 0 and 1. So if I ask you that that so this x2 square will be also a random variable, and if I give this to 0 or 1, so it will again map to again, so 0 square is 0 and 1 square is 1, so this will again map to either 0 or 1. So what I can say that if this is Bernoulli, then this will be also Bernoulli, because it can take 0 or 1 only. Then this will be also Bernoulli. So all of these will be Bernoulli, right? And now if we do the sum of all these, the sum will be again Bernoulli, but let's say that the sum is x and with n times x, right? Because we have n Bernoullis, right? Then this x will get cancelled. Now if we take n tends to infinity, this will be again x, and this x can take the p value where p belongs to 0 to 1. So this will surely converges to p. So the correct answer for this is A, right? Okay, now next we'll move to next question, that is question number 28. So this question number 28, I hope this question is visible to you. Also you can directly download the paper from the website and you can refer the question number, right? So this question number 28, what it is asking that let x and y be independent, two independent random variables with so these two are the chi-square distribution, psi-square distribution, or chi-square, whatever you want to say. So these two are the chi-square distribution respectively, where m and n are positive. So let me first of all tell you that what is what here, notations. So these are the chi-square distributions, and here this m in chi-square distribution, here this m represents the degree of freedom. Here it will represent the degree of freedom. And what is this degree of freedom tells you that and also this, that how many normal distribution, how many squares of the normal distribution you have add up, right? So let's suppose if m is 1, then that will be equal to x square 1. So that means what you have done is that you have taken the square of the normal distribution, right? And if degree of freedom is 2, then what you have done is you have taken the two uh, normal distributions, right? And you have square of the two normal distribution, and you have add up those, right? Okay, so the point is that if where m and n are positive integers, then which of the following statement is true, right? So we have to find that which statement is true. So if you see that, so based on the degree of freedom, that you will have to make the decision right here. And what decision you have to make is you will have to look for the probabilities from certain points, right? So how we can look at this? So okay, so for that you will have to need to know about that uh, if as degree of freedom increases, that means as number of squared normal distributions you add up, then this chi-square distribution converts to normal distribution, right? So as the degree of freedom will increase, so if n is, so let's suppose the degree of freedom is very large, then in this case that it will almost look like a normal distribution curve, right? And let's say if degree of freedom is maybe 3, then the distribution will look like it will be skewed towards left, so maybe it will look like that. So most of the area will be in left side. If the degree of freedom is here 3, that is and here degree of freedom is very large, right? And so 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 from here what we conclude that if you take any point, let's say that you take any point a here, right? And if you check the, okay, so this point is a. Now if you check the probability of x, that random variable is, you will have to find the probability where random variable x is taking value greater than a. So let's check for both the cases, right? For very large degree of freedom and less degree of freedom. You see that the area which have very large degree of freedom, so this is the area you will get, or this is the probability you will get, right? And in case of this less degree of freedom, this is the area you are getting, right? So this yellow one, so probability will be less. So now check the option, right? For m greater than n, for m greater than n, so let's suppose that this is n and this is m, right? Because here degree of freedom, what is this m, and n here is the degree of freedom. So n is greater than m, so probability that random variable x is greater than 0 is greater than equals to probability that y greater than 0. So what it is saying that x is this one, right? M. So with the less degree of freedom is the distribution of x, and with the higher degree of freedom is distribution of y according to option A, right? And so the area, if you will check that y have the maximum area, right? But it is saying that it has the less, so this is the incorrect one. And now let's check this option 2. So in option 2, m is greater than n, right? So m is greater than n, that means here uh, m, that means this x1 will have the more degree of freedom, so this will be m, or you can say this is the distribution of x with degree of freedom m, and this is y with the degree of freedom n, right? Because m is greater than n. In this case, the distribute the this probability, that is probability x greater than 0, will be greater than equal to, so this is the correct one. So B is the correct. The main point is that here you will have to observe the degree of freedom, and you need to have the visualization of the how chi square distribution varies as we increase the degree of freedom, and you need to know that what is this. So this represents the probability that random variable x is greater than a, and this is the area under the curve of the probability density function. That is all. So for this question number 28, option B is the correct one. Okay, let's do few more questions. So these are, I don't think so, these Fisher linear discriminant rule, these are not in the data science syllabus, and this moment estimators. Okay, so we can skip these questions. uh, Not sure about this bivariant random vector, so, and then the regression of y on x, not sure about all these questions. So next okay, so this question I will do tomorrow in next video, right? Okay, so let's do this question number 48. So 48, what we have given that suppose customer arrives at an ATM facility according to the Poisson process, right, with the rate 5 customer per hour, with the rate 5 customer per hour. Okay, the probability that no customer arrives at ATM facility from 1 p.m. to, so for that you need to have the first of all what is the probability distribution function of Poisson, right? So it is e to the power minus b summation from k is equals to 0 to infinity b to the power k divided by k factorial, right? Now let me tell you what is what here. So this b is lambda times t, right? And what is this? T is the rate. At what rate? Here, so t is here 5, so 5 customers per hour, right? And what, the probability no customers arrives at, and here lambda is like lambda t. Okay, so lambda is the uh, that time interval, at which time interval we are looking for, right? So it is the 18-minute, right? Because from 1 p.m. to 1:18 p.m. is 18 minute, and so we should convert this into uh, hour. So it will be 18 divided by 60 hour, 18 divided by 60 hour, right? So from here we can find our value for b, that is 18 divided by 60 into 5, right? So it will be 12 3, so it will be 1.5, right? And if you see that we have to find the probability that no customer arrive at ATM, right? So no customer, that means here the value that this value k is 0, right? Now what we can do, we can find the probability, then it will be e to the power minus 1.5 and summation from k is equal to 0 to 0 b to the power k is 0 divided by 0 factorial, right? So it will be simply e to the power minus 1.5. And if you do the calculation, let me do it, e to the power minus 1.5, so minus 1.5, so it will be 0.223, 0.223. So this is the correct answer for this question. Okay, so this hypothesis testing question we will do in next video, right? Okay, let's do one more question, that is question number 54. So we have given that from x1 to x10 be independent, so it is independent and identically distributed normal random variables. So all these are normal random variables with mean 0. So all these x, not only x1, all. So where mean is 0 and variance is 2, Now we have to find that expected value of x1 square plus x1 square plus dot 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 x10 square, right? So if you observe this x1 square, so and all these are normal distributions, right, with the given mean and the variance, right? So all of these are, I can say, all of these individuals are the the chi-square distribution with degree of freedom 1, right? And I think if this is independent, then what we can write is expected value of x1 square divided by expected value of, or maybe we can write like this. So into expected value of maybe 1 divided by, so x1 square plus x10 square, and all of these are the chi-square distribution with degree of freedom 1, right? And what's the mean of the chi-square distribution? It is k, where k is the degree of freedom, right? So if degree of freedom is 2, then the mean will be also 2. If it is 4, then it will be 4. So in this case, if each individual one is the chi-square distribution with the degree of freedom 1, then we can find the expected value of the all these, right? So here it will be 1 and into 1 divided by, so we can take the individual expectation, right? Because expectation is the linear operation, so we can take, so it will be 1 plus 1 plus 1 plus up to 10, so it will be 1 divided by 10, that is 0.1, right? And don't get confused with this notation, right? Here we have, let me tell you that here that expectation, here we have given that 1 and 2, so these are not here the degree of freedom, right? So each are the chi-square distribution with degree of freedom 1, and the expected value of degree of chi-square distribution is k, that is the number of degree of freedom, right? So 1 divided by 10, that is 0.1. So the correct answer for this is 0.1, right? So let me see if we can do this all this question we will do tomorrow, not tomorrow but in the next video. Okay, let's do one more question. This question number 20. So this question is based on the this confidence interval, right? So we have given that let x1 to xn be a random sample from normal distribution with mean mu and variance 1. So for the n sample, we have the n sample, right? N samples, and the and those all these samples has been taken from some normal distribution, and that normal distribution from where we have taken the sample that have the mean, that is mu, and the variance, that is sigma, is equals to 1, right? Let phi be the cumulative distribution function of the standard normal distribution given 1.96 is equal to 0.975, right? So okay, the minimum sample size required such that the length of the 95 confidence interval is mu does not exceed 2 is, so we will have to find this minimum sample value, right? The minimum sample size, so we will have to find this value of n, right? And if you see that also we have given that the confidence interval for mu does not exceed 2. That means this, if this is the confidence interval, then mu, the length of this confidence interval is 2, right? From here, if that means if mu is here, right, then so here if I ask you that what will be the marginal error, that e, that will be 1, right? Now we will have to find the n, right? So n is equal to uh, and we have given that with the 95% confidence interval, right? And with the 95% confidence interval, the 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 critical level will be, that will be z alpha divided by 2 will be 1.96, this one, right? 1.96. so here we will have the sample value, that will be z alpha divided by 2 sigma, that is the standard deviation, divided by uh, e, that is the error of margin, and square, right? So we can put this value, that will be 1.96, and standard deviation is 1, and this 1, so this will be square, so 1.96 square, it will be approximately 2, sorry, 4, right? So it is 3.84, right? And this number of sample cannot be this decimal number, so this will be 4. So the correct answer for this is 4, right? Okay, and there are few more questions from hypothesis testing that we will do in next video. Then this 2019 paper from statistics we will close, and we will move to 2020 statistics paper. So there are a lot of questions, right, in this paper, and I think I have done only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in one paper we have done, and I have left many questions, right? So you will find a lot of question of probability and statistics from this paper, right? So it's a good, you can keep this in bucket to for revision, and it's a good, the quality of question is very good, and you can expect that this kind of question may ask, right? Okay, that is all from this video. We will do the left question in next video, then we will move to next paper, that is 2020 from the statistics. Thank you.